Today we are going to talk about silvered lens. If one of the surfaces of a lens is silvered from outside, then such a lens is said to be silvered lens. A silvered lens is a combination of a lens and a mirror. Look at the diagram. There, that bluish shaded portion is lens. It looks like a convex lens. In one of the faces of the lens, a silvered coating is there. That silvered coated portion, it acts like a concave mirror. So it's a combination of convex lens and concave mirror. Light can enter through the transparent front side of the lens and get reflected by the silver coated rear surface. Hence light travels 2 times through the lens. The diagram that clearly explains how the silvered lens is made up of. Now we are going to learn about silvered lens. In the case of silvered lens, as I have explained earlier, the ray travels in the air medium. After incident on the front side of the convex lens, it travels through the lens, and then again after getting reflection from the mirror portion, again it gets reflected. Therefore, through the lens, the light ray travels for 2 times and it gets reflected from the mirror portion of the concave mirror. Just behind the lens, this portion is silvered. Therefore, this portion acts like a converging mirror, concave mirror. This portion acts like a convex lens. So, this combination is called as silvered lens. The name of the lens is called, what is this? Silvered lens. So, silvered lens is a combination of convex lens and converging mirror, concave mirror. Look at the sign conventions. This table will be definitely very much useful for you to derive the further derivation. Here, let's see about the lens portion. In the case of lens, the focal length must be taken as positive. Are you clear? And the power of the lens portion also must be taken as positive. In the case of mirror, in the case of converging mirror, concave mirror, focal length must be taken as negative, but power must be taken as positive. If both are combined, you will get the silvered lens. In the case of silvered lens, the focal length must be taken as negative and the power must be taken as positive. So, by using this sign convention, we are able to derive the expression for power of the lens. So, here, in this case, how to write this? Here the combination, the power of the complete combination silvered lens is, how will you write? Power of the silvered lens is equal to power of the lens portion, first entry. For the first entry I am writing power of the lens. After getting reflection from the mirror, again we have to go for the mirror portion. Therefore, I have to write power of the mirror plus again it gets reflected through the lens. Therefore, power of the lens must be considered. Since the light ray travels for 2 times through the lens, I have to write 2 power factors in the case of lens. After that, these 2 are equal. Therefore, power of the silvered lens is equal to 2 times of the PL and plus PM. You have to write like this. Don't forget, this is the important expression. Are you clear? Now we know all the sign conventions. By using that we can write. So here, how will you write? We will write the expressions one after the other. Power of any, whether it may be a lens or it may be a mirror, power is the reciprocal of the focal length. So therefore, all power factors must be converted into focal length form. So how will you write? Power of the silvered lens. How will you write? Power of the silvered lens. That is a reciprocal of this factor. So how will you write? 1 by minus of focal length of the silvered lens must be written, which is equal to 2 divided by, here power of the lens is given. Look at the power of the lens, that is a reciprocal of the power of focal length of the lens. Therefore, how will you write? Here we can write it as 1 by F, L can be written. So this factor is in terms of positive. And then come to in the case of mirror, plus sign must be written. as given in the formula, plus sign must be written within the bracket, the power of the mirror to be written. Power of the mirror is nothing but reciprocal of this focal length, but it is in negative sign. Therefore, 1 by minus of focal length of the mirror must be written. So this is the formula which is written in terms of focal length. This is written in terms of power. Are you clear? So here on the whole, what it shows, it is that silvered lens is the combination of lens and the mirror. So either you can use this formula or you can use this formula. This formula is very much useful for calculating the power. This formula that could be used for calculating the focal length. Okay. So either any one of them can be used. By using this, either power can be calculated or focal length can be calculated. Okay. So very important formula here. By using this simple formula, we are going to do one problem also. Okay. Now we are going to solve the problem number 6.18. This is the newly introduced problem related to silvered lens. Because to understand the silvered lens in a very better way, this problem must be solved. Only then you are able to understand very thoroughly about the silvered lens. Look at the descriptions which are given in the problem. The radius of curvature on either side of the lens is how much? R1 is equal to 30 centimeter, R2 also equal to 30 centimeter. So R1 and R2 both are equal. The refractive index of the lens part is 1.5. Okay, you are asked to calculate the focal length of the silvered lens as well as the power of the silvered lens. I have written all required formulas here. First let's calculate the focal length. Later we will go to the power part. Okay. So you should know the lens maker's formula. With the help of lens maker's formula, we are able to find out the focal length of the lens portion. So I already have written the lens maker's formula. Here n value is given. Substitute here. R1. What is R1? R1 is the radius of curvature of this portion, first surface. R2 is the radius of curvature of the other portion. Since it is the mirror portion, R2, that one must be taken as negative. The radius of curvature of the mirror portion must be taken as negative. So first I will substitute the lens maker's formula 1 by FL. What is 1 by FL? From which we are able to calculate the focal length of the lens by using lens maker's formula. N minus 1 in bracket 1 by R1 minus 1 by R2. Here that R2 must be taken as negative because this is mirror portion. Are you clear? 1 by FL is equal to, substitute here, instead of n substitute 1.5. 1.5 minus 1 divided by 30 can be substituted, and then minus of, already I have told this R2 must be taken as negative, therefore here minus 30 must be written. Are you clear? R2 value must be taken as minus 30. So what will happen now? 1 by FL is equal to, after calculation this one becomes 0.5, after that this one becomes 1 by 30. If both the two negatives are combined, you will get 1 by 30. Are you clear? So after that what will happen? 0.5 into 2 divided by 30 you will get. Are you clear? So 0.5 is nothing but 1 by 2 into 2 divided by 30. After cancellation you will get 1 by 30. 1 by 30, which is equal to how much? 1 by FL. You just compare this and this. You just compare the denominator value alone. FL is equal to 30 centimeter. So the focal length of the lens is found out. How much? 30 centimeter by comparing the denominators. The same FL, that one must be written in terms of meter also. That is very important. So 30 centimeter can be written as 0.3 meter. So FL is found out. Okay. Next we are going to find out the focal length of the mirror. How will you find the focal length of the mirror? Simple formula. Focal length of the mirror is equivalent to radius of curvature of the curved portion this side divided by 2. But here this portion that is made up of mirror, no, therefore it should be taken as negative. So therefore you substitute the value of 30 here in terms of negative. So minus 30 centimeter divided by 2. Therefore focal length of the mirror portion will be equal to minus 15 centimeter. Are you clear? Minus 15 centimeter. So this value could be kept as it is. So now we have found out the focal length of the mirror also. So focal length of the mirror is equivalent to minus 15 centimeter. So keep the two values aside. So whenever it is required, we can substitute. Okay. Now we are going to calculate the focal length of the silvered lens. This formula can be used. Minus 1 by, that is focal length of the silvered lens, is equal to 2 divided by focal length of the convex lens portion plus, and then within the bracket we have to write the focal length of the mirror portion, that should be taken as negative. So this is a very fundamental formula. Okay, so in which we have to substitute all the known values. Already we have calculated the focal length of the lens and focal length of the mirror. Substitute here. Minus 1 by focal length of the silvered lens is equal to 2 divided by focal length of the lens is how much? 30 centimeter. Therefore we can write it as 30 plus within the bracket 1 by Fm. What is the value of Fm? Minus 15. So here one minus 15 can be written. Are you clear? So minus 1 by focal length of, we will continue the step here. Minus 1 by FSL. FSL means focal length of the silvered lens, which is equal to 2 divided by 30. Here that plus sign is there. If this 2 minus, they can be simplified as plus. 1 divided by 15 can be written. After simplification you will get 1 divided by 7.5. Are you clear? You just compare this FSL with the denominator of the answer. So FSL it becomes 7.5. Note down that. Both the two denominators, that one both can be compared very easily. After comparison, this FSL is compared with the denominator, you will get FSL will be equal to, this minus sign can be written here. Finally you can write it as 7.5 centimeter. So this is the focal length of the silvered lens, given silvered lens. Okay, the same value that is given in centimeter, that could be converted into meter also. After conversion you will get minus 0.075 meter can be written. So this is the method of answering the final answer in terms of SI system. Okay. Finally we are going to calculate the power of the silvered lens. Here some important steps are there. So this is the formula to calculate the power of the silvered lens. Already we have calculated FL, and FL means focal length of the lens is calculated. FM is nothing but focal length of the mirror is also calculated. That is in terms of negative. While substituting, you can substitute the negative. Are you clear? That is a simple formula. So here in the formula, that minus sign is there. Don't forget, in the formula negative sign is there. Are you clear? Substitute now. 2 in bracket you can substitute FL. FL is equal to 30 centimeter substituted, and then 1 divided by minus of FM value is how much? 15. That is also given in terms of minus. Are you clear? So 2 divided by 30 plus 1 divided by 15. So substituted, both are substituted. After simplification, the calculation must be done properly with the help of calculator or with the help of your algebra knowledge. After that you will get 4 divided by 0.3 you will get. Okay, 4 divided by 0.3 you will get that is equal to 13.13 diopter. Are you clear? Both are in centimeter. That should be converted into meter. Later you can do the calculation. Are you clear? So how it can be done? Tell me. 2 divided by 0.3 can be written. Are you clear? And then here you can write 0.15. So later you will get 4.4 divided by 0.3. In the final answer you will get it as 13.3 diopter. This is the power of the silvered lens. Are you clear? So in the final step you have to convert the value into which one? That the centimeter value must be converted into meter value. Only then you will get the answer.